CITS section 1.6 is on variation and applications. Now we have direct variation, which we've all worked with, and inverse variation. This is just a little tweak on it where they add the joint variation and the variation as the nth power. Just a quick review for you. Direct variation is any equation that can be written as a form y equals kx, okay, where k is a constant and called our constant of proportionality. Y is directly proportional to x, would lead us to y equals kx, okay? And again, in all formulas, k is a constant of variation. Now, direct variation as an nth power would read y varies directly as the nth power of x. Okay, so they'd say something like y varies directly as the height to the fourth power, or something like that. So that would be read as y equals k x to the n, the nth power of x. Okay, remember, k is in every one of these. That's our constant that we're trying to find. Inverse variation just puts the variable on the bottom. Y varies inversely as x, or they could say y is inversely proportional to x. Again, we could do the same thing with the nth power. Y varies inversely as the nth power of x. So I'd have my k over x to the n. And then we have joint variation, where the two variables are multiplied together. And they could do joint on the bottom also saying inverse jointly. But this is y varies jointly as x and y. So therefore, they're all multiplied together. Now, it goes pretty quick here, so I'm just going to kind of fly through them. Number 8, 10, and 11, they're just asking us to write the general description, and then I've got 4 examples of how to work them out. So, u varies directly as v and inversely as a square of w. The u varies directly gives you your start, u equals k. So, varies directly as v, so v is on the top, inversely as the square of w. W squared is on the bottom. Okay, there's your general equation to start your calculations with. A varies jointly as h and the square of r. Jointly means they're just together. So A varies, gives me my A equals k, and jointly as h and r just gives us the general form. F varies jointly as m1 and m2, and inversely as the square of d. So F varies, okay, and jointly as m1 and m2. m1 and m2 are on the top, inversely as the square of d. D squared is on the bottom. Now what they're going to do from that is just give you values basically to plug in. You're going to solve for k, and then they'll ask you to find something. Okay? So on number 14, m is directly proportional to n. That gives us a general equation, m directly proportional to n. And m equals 92 when n equals 23. So 92 equals k times 23. Solve it out. Okay, and then I want you to write the equation again. So there is our general equation, m equals 4n. Okay, seems pretty straightforward, doesn't it? Got just a few examples here for you. Okay, number 24, pressure and depth. The pressure of a liquid exerts at a given point on a submarine is directly proportional. Okay, so we have pressure is directly proportional to the depth of the point below the surface of the liquid. So directly proportional to the depth. Okay, pretty straightforward problem. If the pressure at the depth of 3 feet is 187.5, so the pressure is 187.5 at a depth of 3 feet, divide both sides by 3, you get k equals 62.5. They want to find the pressure at a depth of 7 feet. So I'll rewrite the equation. Pressure equals 62.5 times the depth. 62.5 times 7. So the pressure at 7 feet is 437.5 pounds. Okay, pretty straightforward, huh? Number 31. Jet engine noise. The sound intensity of a jet engine measured in watts per meter squared is inversely proportional. Okay, so sound intensity. Intensity is inversely proportional to the square of the distance. So inversely to the square of the distance between the engine and the airport ramp worker. Okay, so that's all they give us. For a certain jet, the sound intensity is 0.5 watts per meter squared when the distance is 7 meters. So K, whoops, didn't square that 7. So K equals 0.5 over 49. Multiply together, I get 24.5. So there's my general. I'm going to rewrite the equation. I equals 24.5 over d squared. And now they want to find that intensity when we're 10 meters from the jet. So I is going to equal 24.5 over 10 squared. I ends up being 0.245 watts per meter squared. Okay. Last one. The maximum load of a cylindrical column of circular cross-section can support varies directly. So the maximum load varies directly as the fourth power of the diameter. So the diameter to the fourth. And inversely as the square of the height. Okay, so there's our general equation. Column is 2 feet in diameter and 10 feet high. So my load is, and it can support 6 tons. So that's going to be a 6. 2 feet in diameter and 10 feet high. So I get 100 times 6. I've got 600 equals 16K. So K ends up being 37.5. Rewrite the equation. Load equals 37.5 times diameter squared over h squared. And now they want to find out how many tons a column 3 feet in diameter and 14 feet high can support. So 37.5 times 3, and that should be the fourth, and 14 feet high. Okay, punch that in, and we get a load that can support of 15.5 tons. Now I know this section seems pretty simple, but it is part of the section that we're doing, and a lot of things can be found using these variation applications, so it's something we kind of need to cover.